Hi, fifth graders. So we're going to work today on making sure we really understand the relationship between fractions and decimals. That is, we want to make sure you understand that fractions and decimals are the same thing. Decimals are a type of fraction. So we're going to work on that a little. So first off, let's look at our problem. What's 1/2 of 3/4? Which you know, that's the same as asking what's 1/2 times 3/4. So let's draw ourselves a model. I'm going to divide it into half. And how many halves am I going to shade? 1, because it's 1/2 times 3/4. And then I've got to do fourths going the other way. And how many of those guys am I going to shade? 3 of them, because it's 3/4. Get that one, and that one, and that one. So then how many did I double shade? Right there, that's 3/8. Now let's check it mathematically. 1/2 times 3/4. I'm going to multiply across. 1 times 3 is 3. 2 times 4 is 8. 3/8. Looks good. Now let's check out this problem. We have 2/2 of 3/4. So how does this problem compare to the warm-up problem? Well, it's 2/2 instead of 1. And I just want to remind you that 2/2 is the same as 1 whole. So 2/2 is the same as good old-fashioned 1. But let's check out what that looks like in an area model. So I'm going to draw my box, and I'm going to start with halves. And how many halves am I going to color? Well, 2 halves, because I have 2 of them. So I'm going to shade in this one, and I'm going to shade in this one. And then I'm going to divide it into fourths. And then I'm going to shade in 3 of them. 1/4, 2/4, 3/4. So since I did halves and fourths, I'm going to make this line a little darker, I divided my whole box into eighths. So what I have double shaded is 6/8. Now let's check out mathematically. 2/2 times 3/4. Let's multiply across. 2 times 3, 6. 2 times 4 is 8. All right, looks like I'm on the right track. But wait, there's more. So how does the size of our product, 6/8, compare to the size of the original fraction that was 3/4? Well, check it out. If I use our old do it to the bottom, do it to the top trick, I get 6/8. Now when I do that, do it to the bottom, do it to the top, am I changing the value of the fraction? No. 6/8 and 3/4 are the same, because check it out. Here's my pie. Let's make it a key lime pie, because I really like key lime pie, guys. Key lime is delicious. And I'm going to shade in 3/4. Now watch as I change my denominator. Watch as I change it from fourths to eighths. Now, 1, 2, 3, 4, 5, 6, 7, 8. All right, I've got eighths instead of fourths. Do I have the same amount of pie, though? Yeah, I just divided it up different. I divided it into eighths instead of fourths. So I had 3/4 shaded, but now I have 1, 2, 3, 4, 5, 6/8 shaded. So 6/8 is the exact same number as 3/4. If I ate 6/8 of a pie, that's the exact same as eating 3/4 of a pie. Hey, check it out. Forget eighths. Let's go to 16ths. Well, now I have 12/16ths, but it's still the same amount. So, if I, do it to the bottom, do it to the top, I change the digits. I can change the numbers, but I don't change the value of the number. That value is still the same. So how is it possible that our quantity is not changed? That's how. Because so long as I do the exact same thing to the top and the bottom, it doesn't change the value of a fraction. So remember how I said that 2/2 is the same as 1? Our beginning amount of 3/4 didn't change because we multiplied by 1. Well, what happens when you multiply by 1? Nothing. 2 times 1 is still 2. 3 times 1 is still 3. 26,000 times 1 is still 26,000. So 3/4 times 1 is still 3/4. And 3/4 times 2 halves is still 3/4 because you're just multiplying by 1. We just got a different kind of 3/4. So name some other fractions that are equal to 1. Well, how about 3/3? Or 7/7? Or 100/100? Or 987 987ths? Those are all equal to 1. So let's look at 3/3 of 3/4. So keep in mind 3/3 equal to 1. So we know our answer is still going to be 3/4. It's just going to be a different flavor of 3/4. Let's check it out. Here's our area model. Alright, I'm going to divide it into thirds. And I'm shading all 3/3 because it says 3/3. Okay, and then on the next, we do fourths. And how many fourths do we shade in? 3. So let's go ahead and shade those 3/4. Shading, 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 and shading. So how many do we have double shaded? Well, that appears to be 9/12. Let's check our work mathematically. 3/3 times 3/4, multiply across. 3 times 3 is 9. 3 times 4 is 12. Now hold on, let's reduce. Let's turn it into an easier version of itself. So I'm going to divide the top and bottom by 3. And since I'm doing it to both, I'm not changing the value. I'm just making it easier. 3/4. But hey, that's what we started with. So multiplying by 1 never changes the value. Is our product still 3/4? Yes. So go ahead and list 3 multiplication expressions involving 3/4 that would give us a product equal in size to 3/4. So you're going to do this on your own, and raise your hand when you're ready for me to check you off. Once you're finished with 11, I'd like you to give these 2 a shot. If this is taking longer than 3 or 4 minutes, then you need a little extra help, so please raise your hand and ask. So now we're going to work on using this trick to turn fractions into decimals. So right now we have 1/5 times 2 halves. So let's just do it the easy way. We're going to do it mathematically. Set it up, multiply across. 1 times 2 is 2. 5 times 2 is 10. 2/10. Now, how does that help us put it in decimal form? Well, decimals are fractions that only come in tenths, hundreds, thousands, 10,000ths, and so on. That's the only flavor they come in. So now that I have my fraction in tenths, well, I can just write it as a decimal. 2/10. Boom. So 2/10, like that, 0.2, is the same as 1/5. Exactly the same. So 1/5 equals 2/10. Did we change the value of 1/5? No. Here's that pi again. And divide it into fifths. Ugly fifths, but still fifths. And I'm going to color 1/5 in, because that's how much I feel like eating right now, 1/5 of a pie. And then look, watch me turn them into tenths. So now I'm at 2/10, just like the solution we got. Didn't change the amount of pie I ate, just changed how many pieces it was divided into. So how can we change 3/5 into a decimal? Well, you try. Go ahead and change 3/5 into a decimal and show me, put a hand in the air when you're ready for me to check. So when we were experimenting with fifths, we turned those into tenths, and that was really easy. But now we have fourths. Can we turn a fourth into tenths? No. Because if we count by fours, 4, 8, 12, we skip right through 10. So what's a decimal fraction denominator we can rename 1/4 to? And how could we do it? Well, we know decimal fractions only come in a very few flavors. They come in tenths, and then the next one they come in is hundredths. If I count by fours, will I get to 100? I will. So to turn fourths into hundredths, I have to multiply by 25. So watch. 1/4. Remember, I'm not trying to change the value, so then I can do my do it to the bottom, do it to the top trick. I get 25 hundredths, which I could also write as 25 hundredths. So is 25 hundredths the only decimal name for 1/4? Well, we could do 250 thousandths. But since adding that 0 doesn't really change anything, this is still basically the same as 25 hundredths. All right, your turn. Show me 2/4 as a decimal, please. Raise your hand when you're ready for me to give you a smelly star. So our last problem, 1/8. If I count by eighths, 8, 16, I blow right past 10. And if I count by eighths, I'm not going to land on 100 or 1,000 either. So we can't get to tenths or hundredths. Can't get to thousandths. So here's the trick for 1/8. I pull out my handy dandy calculator and I put in 1 divided by 8. And it'll give me 125 thousandths. So that's always the last resort. Numerator divided by the denominator. So there's some denominators like eighths that are very difficult to put into decimal form. So eventually you can get there. All right, let's get out that problem set. Who's got problems? You've got problems. Good luck.